All right, so we are now past derivatives, and now we are working in the antiderivative. So you're going to see some terminology. We're going to switch it up a little bit. And basically what we're doing is we're going in the reverse order. So when you're working on these, what you have to keep in mind is when you get a question, the question is giving you the derivative. You have to take the derivative back to the original function. Okay, so with derivatives, you are given an original function and you find the derivative. Now we're going to go in the opposite direction. Now we're going to go in the antiderivative, so the opposite. So here's just some terms and some symbols that you're going to need to know. So the first one is called antiderivative. So antiderivative just means the opposite of the derivative. These are also called indefinite integrals. Okay, and they're indefinite because they're not specific. Okay, so they're just kind of in general. And what you're doing is what's called integration. Okay, so all of these terms just mean you're finding the antiderivative. They all mean the same thing. Just like with derivative, differentiation, finding the instantaneous rate of change, those are all derivatives. Now we're going in the opposite direction. So if you remember, let's go over the power rule for the derivative. So the power rule said if you have a function, the derivative of this function, is you bring your exponent down and you multiply, and then you subtract 1 from your exponent. Okay, that's finding the derivative. When you're finding the antiderivative, the symbol, that's your integration symbol. Okay, and what you're going to do is you're going to do the opposite. So when you're finding the derivative, you multiply and then subtract. When you find the antiderivative, you add and then you divide. Okay, so not only do we do the opposite operations, we do them in the opposite order. So when you found the derivative, you dropped it down and multiplied, and then you subtracted 1. Now what we're going to do is we are going to add 1 and then divide. Okay, so we're going to go in the opposite direction. Now, here's what we're actually doing. If you have a graph, okay, before, what we were doing when we were finding the derivative is we were finding the slope at a very specific point. Now what we're doing is we are finding the area under the curve. That's what antiderivatives are, is being able to find the area under a curve. So it's a very different thing than finding slope. Now we're finding area under a curve. So in order to do that, let's give you an example. So let's say we have x squared dx. Now, this is all just functional. This is just notation. So remember, the long s is the integral sign. Then you have whatever function you're going to use. And then this is just a terminology, dx. So remember, when you were finding the derivative, it was finding the derivative in terms of x, so d dx. Now you're finding the antiderivative of the function in terms of x. Now, where this comes from is if you're finding area under a curve, what you're literally doing, so we're going to find area under this curve, is we're taking and we're using finding the area of these, sorry, that's my phone. Turn it down. Sorry about that. Okay, so what you're doing is you're finding the area. Well, this right here, this distance, is what we call dx. It's just a distance. Then what we're doing is, remember, area is just length times width. So my length is the function, right? It's the y value of the function. So it's this length times this width. So that's what you're literally doing. This is the height of the function, or the length of the function, times the width of the function. So what you're doing is you're getting the area of each of these pieces, okay, all of these pieces, and then you're adding them up. Well, this elongated S can represent sum. So this is literally telling you what you're doing. You're finding the sum of all the rectangles underneath your curve. Okay, that's what the notation means. So how do we do that? Well, we're going to use the power rule backwards, because instead of derivative, we're finding the antiderivative. So the power rule backwards. So what you're going to do, I'm going to do this in a different color. You are going to add 1 to your exponent. Okay, we subtracted 1 over here. Now we're going to add 1, and then we are going to divide by the new exponent. Okay, so we're adding 1 and then dividing by the new exponent. So the antiderivative is x cubed divided by 3. Okay, now I can rewrite this as 1/3 x cubed, right? Because there's an assumed 1 right there. Well, these you should never get wrong, because if I take the derivative of this, it should take me back to my original. So if I take the derivative of this, I bring my 3 to the front and I multiply, and then I subtract 1. So 3 times 1/3 is just 1. So it is 1x squared, or just x squared. So these are very easy to catch any mistakes that you've made. All you have to do is, once you add 1 and then divide by the new exponent, to check, you find the derivative. Use the power rule to find the derivative. Okay, so let me give you another one. So again, this is 12.1, finding the antiderivative, and you are integrating, or you're using indefinite integrals, and this is called integration. So the integration term is like the differentiation term. So that's the act of finding the derivative is differentiation. The act of finding the integral is integration. All right, so let's try another one. So the antiderivative of 3 dx. And again, this dx is just notation. All right, we're finding 3 in terms of x. If this was dt, now I'm finding the antiderivative in terms of t. So just because you're used to x, that's why we use dx. But it's just notation is all it is. All right, so I'm looking for the indefinite integral of 3 in terms of x. All right, now, remember the rule is for the antiderivative is we're going to add 1, and then we're going to divide by the new exponent. Well, remember, this constant has a variable of x to the 0 power. It's not there, it doesn't show it, but it is x to the 0 power, because x to the 0 power actually equals 1. So that's actually saying 3 times 1. So what you're going to do is you're going to add 1, and then you're going to divide by the new exponent. 0 plus 1 is 1, so I'm dividing by the new exponent. So my antiderivative is 3x. Now, I have to have in plus c. When you're dealing with indefinite integrals, we're dealing with a whole family of functions. So let me give you a visual for that. So this is the function x squared. Okay, that's our function x squared. Well, if I drop this function down 2 steps, I have the same function, but now it's x squared minus 2. If I lift that same function up 4 steps, I have x squared plus 4. All right, so there's a whole series of parabolas here. Well, if I find the derivative of this, so if I find the derivative of x squared plus 4, using the power rule, drop this to the front, I get 2x. If I find the derivative of x squared minus 2, Drop this to the front, it's still 2x. The derivative of x squared is still 2x. So what this means is I have a whole family of functions, okay? A whole family of them. So this plus c is basically your constant. You're adding some constant to the function in order to show the whole family of functions. So when you are finding indefinite derivatives, or I'm sorry, indefinite integrals, make sure you always put plus c. How do you know it's indefinite? Well, there's no numbers on this integral sign. Okay, indefinite means it's just in general. All right, so here, let's try another one. Let me erase this. So remember the plus c, which I should have done that on the first one. All right, here we go. The integral of 10x squared in terms of x. Okay, so again, we are going to, I hope this shows up on the video, add 1, and then divide by my new exponent, and my new exponent is 3. So the antiderivative, or the integral of 10x dx, is 10/3 x to the third power plus c. Okay? So add 1 and divide by the new exponent. Now, what if you have one like this? And I'm just giving you several different examples that you're going to see on your My Math Lab. How about x to the negative 3 dx? Okay? So again, all you're going to do is you're going to add 1, and then we're going to divide by the new exponent. So the new exponent is negative 3 plus 1, which is negative 2. So it is x to the negative 2 divided by negative 2 plus c. All right? Another way to write it is negative 1/2 x to the negative 2 plus c. Another way to write it is a negative 1 over 2x squared plus c. All of these are the same thing. So make sure that you understand how to write it. It just depends on the technique that you use. Make sure you understand how My Math Lab wants you to write it, how they want you to write the answer. Okay? All right. Now let's try some specialty ones. So if you remember, the derivative of ln of x is 1 over x. Okay? So remember, when you're finding the antiderivative, you've been given the derivative. You have to go back to the original. So if I wanted you to find the antiderivative of 1 over x dx, this is going to be ln of the absolute value of x. Super important to put absolute value signs because you cannot have a negative ln. Okay, no negative logs. That's not in the real number system. Remember, the derivative of e raised to the x power was e to the x. So the antiderivative of, say, 3 e to the x dx is 3 e to the x plus c. And again, I should have put plus c there. That's easy to miss. Because we're doing indefinite integrals, you need to put in your plus c. Okay? Now let's try a couple with fractional exponents. So if you had the antiderivative of the cube root of x squared dx, okay, so we are going to rewrite this as the antiderivative of x to the 2/3 dx. Now I'm going to apply plus 1, divide it by my new exponent. So do you remember at the very beginning of the semester when we went through and I was giving you a review and I said you're going to rewrite your 1 as a common denominator? So 1 is the same as 3/3. The reason why I picked 3/3 instead of 4/4 or 5/5 is because I'm using a denominator of 3. So now it's very easy to add my fractions. All right, and you want to keep it as a fraction. Do not change it to a decimal. Okay? All right, so what I do is when I know I'm working with a fraction, I'm adding 1, so I just change that 1 to a fraction right away, depending on what my denominator is. So this ends up being x to the 5/3 divided by 5/3 plus c. Okay, and so as you remember, when you divide by a fraction, you flip it and multiply. So this is actually 3/5 x to the 5/3 plus c. So all I did is I took this divided by 5/3 and I flipped it over and multiplied. Okay? All right. So now with antiderivatives, what you can do is you, just like we did with derivatives, where you can take part by part. So let's see. The antiderivative of 3x times 4 plus x dx. Okay, so there is no product rule or quotient rule in antiderivatives, which is very good news. So what you're going to do, well, there is, but we're not going to have time to do it this semester. So what you're going to do is you're going to distribute this through. So you have 3x times 4 is 12x. 3x times x is 3x squared. And now I'm going to find the antiderivative of 12x plus 3x squared. I can take the antiderivative. This is what it shows in your My Math Lab. I can take the antiderivative of each piece. Okay? So antiderivative of 12x, this is x to the first power, so I'm going to add 1 and then divide by the new exponent. So I have it equals 6x squared. This one, I'm going to add 1 and divide by my new exponent. So 3 divided by 3 cancels. So I have x cubed and then plus c. So you can take each piece. This is how My Math Lab breaks it down for you. You really can just use it right here and just know I'm taking the antiderivative of each term. So this one was a 1. I added 1 and divided by 2. So I get 6x squared. This is I add 1 and divide by 3. So plus x cubed and then plus c. So don't forget the plus c when you're doing the indefinite integral. Okay. So I did that. I did that. I'm looking through your homework to make sure I've covered everything. Okay. Last couple. So if you have one that looks like this, the antiderivative of, say, x to the 7th minus 3x squared all over x to the 5th dx. Okay? So again, you can just simplify. You know that when you divide with exponents, you subtract the exponents. So x to the 7th divided by x to the 5th is x squared, because 7 minus 5 is 2, minus 3. 2 minus 5 is negative 3, so x to the negative 3rd dx. So all I've done is I've simplified this. I've divided x to the 7th divided by x to the 5th, I get x squared. Negative 3x squared divided by x to the 5th, I get negative 3x to the negative 3rd. That's a negative. Okay? Now I can find the antiderivative. I'm going to add 1 and divide by my new number. I'm going to add 1 and divide by my new number. Negative 3 plus 1 is negative 2. So the antiderivative is x cubed over 3 plus 3 halves x to the negative 3, x to the negative 2 plus c. Or I can rewrite it as 1/3 x cubed plus 3 over 2x squared plus c. Now, I believe My Math Lab will let you write it this way, but if you want, you can write it that way. But I believe they will accept it with a negative exponent. Okay, so that is the basis of antiderivative. I'm going to stop there, and then I'm going to do the application of it.